Thank you all for taking the time this morning to attend this webinar on vehicle to grid, the future. We've got some great speakers lined up today who are going to provide a lot of insight into developments in the UK and future potential regulatory insights, and also how this works from a DNO's perspective. So we're going to start off with looking at the vehicle to grid benefits and learnings. This is based broadly on the UK cohort of vehicle to grid projects. We're then going to look at vehicle to grid connections, a DNO perspective. So we're going to look at the innovations that UKPN have brought in to try and improve the application and installation process. We're going to have a Q&A, and then we're going to move on to an update from Ofgem on how they are planning to decarbonise the electricity network at the lowest possible cost. So this is looking at now and future actions from a regulatory point of view. Before closing the webinar session, you will then have an opportunity to join in the pre-scheduled meetings. My colleague George is manning the YouTube chat, so we have 2 Q&As and quite a lot of time of Q&A. So this is all about actually getting a bit of a two-way conversation going on. So please ask George if you have any questions for our panelists, and then I will ask those questions of the proposed panelists. So without further ado, and thank you very much, I will move you on to Marco Landi, Innovation Lead for Vehicle to Grid, and Evie, Smart Charging at Innovate UK.
Marco, you're on mute.
Sorry, some technical difficulties here. Can you guys hear me? Hello? Yeah, okay, so start again. Sorry, this presentation is intended to give you a gist of what's happening in the UK on vehicle to grid, what vehicle to grid is, and what developments can we foresee in the near future. So first of all, for the ones of you that don't know what Innovate UK is, basically Innovate UK is the innovation agency for the UK. Our target is to develop, to make businesses a commercial success. We normally do that through either one of two ways, either by connecting businesses to each other, where there is we can see a business opportunity, we can suggest and connect two businesses together, or by deploying funding. And normally in our team, we work with government departments such as Trolove or PACE or CCAV to deploy their innovation funding into areas where we can perceive to be a barrier. So I thought that the best way to start probably is to by a description of what it is, what vehicle to grid is. I'm sure that if you are participating into this webinar, probably you know that already, so I won't spend too much onto it. But essentially, what we consider as what we include in the definition of vehicle to grid are all the technologies that achieve a tighter integration of EV with the power grid. So EVs, they can act as what we call a dump load, as in start charging as soon as you connect them. But if you are a little bit more smart around it, you can use the EV as a controllable load. So you can defer the load, you can provide down regulation, and that goes normally under smart charging. But you can also bring that one step further and include bidirectional energy transfer. So essentially, the energy can not only flow from the grid to the vehicle, but also from the vehicle to the grid. Of course, both in case of smart charging and vehicle to grid, you need a bidirectional communication between the vehicles and the grid operators. We'll see later what's the how many actors need to be involved in this framework. In terms of services that you can provide, I mean, generally speaking, there are a range of services that a grid-connected vehicle can provide, being essentially a battery connected to the grid. These go from customer-level programs, so in terms of backup power, of demand reduction, to distribution services, or to bulk power system services. One of the things that I'm keen on every time on repeating is that essentially vehicle-to-grid is not intended to use the vehicle as a replacement for power plants, but as an aid to the system to make the power system work better. So why are we looking at vehicle-to-grid? Essentially, the first and foremost driver is essentially an economic one. If you look at the system, the wider system, essentially EV are going to demand quite a lot of power. These are estimates from National Grid Future Energy Scenarios. In 2017, which is the last one in which they assumed that electric vehicle could be down charged, so with no smart charging and not vehicle to grid. They estimated that the additional load brought from EV in 2050 was between 5 to 18 gigawatt. In more practical terms, that additional power brings an additional burden on the distribution network, and ATI estimated that to be £17 billion by 2050 in terms of cost reinforcement needed to support that power. And this is if we do nothing with the vehicles and we treat them simply as a load. I just want to point out that while the economic driver is important, is not the only one behind vehicle-to-grid. There are some social benefits as well. For example, you reduce the vehicle-to-grid. A recent study from Imperial showed that vehicle-to-grid is actually carbon negative, as in it can definitely help in reducing carbon emissions. There are some system savings. But in terms of going to specifically what's the impact on the £17 billion that I showed before, already if you apply smart charging, the same study showed that can save up to £8 billion. When you start factoring in vehicle-to-grid into this mix, actually vehicle-to-grid, again, this is the figures here taken from a study at the Imperial College. They were showing system-wide saving between smart charging and system-wide savings related to vehicle-to-grid in the best scenario of £3.5 billion a year, which is quite considerable. I will get into that later. Just remember this figure, but I will get into that later with a problem related to this figure and how they're distributed across the value chain. Other interesting thing, these figures are taken from the National Grid Future Energy Scenarios from 2019. The interesting thing to notice is that these are their study scenarios for 2050. In none of that, there is zero participation to smart charging and vehicle-to-grid. In other words, smart charging and vehicle-to-grid are assumed to be integral to the future scenario, to the future landscape of the energy system. How they come into play, essentially, while we're considering them, how is the energy system is changing and is accounting for electric vehicles and what role they can play. Well, essentially, we're transitioning from a vertical integrated power system, that is, the flow of power goes from the power generating units through power transmission distribution to the loads, and now it's becoming more like an integrated web of connection, both in terms of communication and power flow that include distributed and renewable energy sources, including the existing power generation, but also includes some advanced grid monitoring, the electric vehicles, but also smart homes that are not simply loads, but can be also load and generating device, some of them by integrated storage. So essentially, the gist of it is that everything is becoming more complicated, but in a way, by this complication, you can harness a lot more possibilities and a lot more efficiencies and synergies between different systems. I mentioned before that the landscape that compose the actors involved in realizing vehicle-to-grid are actually, there's quite a number of actors. Here I named a few. It's not an exhaustive list by all means. But the general idea is that if you want to have a full grid and vehicle integration, you need to have at least the vehicle, of course. You need to have the charge point and who operates the charge point. You need to have an aggregator, which basically manages a number of charge points and makes them available as a single entity, and potentially a VPP that can be two different roles, or basically merged into one with the aggregator that allows this aggregated entity to actually access the markets. And then you need the energy markets and the actors on the energy markets as well. So it's not an easy landscape, but that variability in terms of how you compose this value chain actually opens up quite a lot of possibilities for innovation in terms of business modeling and proposition to customers. So in the UK, we launched in 2018 a program of 20 projects that range from feasibility studies to research and development to real-world demonstrator. It is still the world's biggest vehicle-to-grid program still to date. We've had few hiccups. I'll talk about that later, but we've had few hiccups in terms of total ambition of the program. But still, it is the biggest one. It is the biggest one in the world, and covers from development of customer proposition to development of hardware in terms of charge point, in terms of onboard chargers, and in terms of demonstrators. It covers from van to buses to basically domestic application, fleet applications. And just to give you an idea of how many, this is not an exhaustive list by any means, but these are basically some of the organization involved. This is just to say that there is relevant interest on vehicle-to-grid. It is a niche at the moment from a commercial point of view, but it has quite a good potential, and that's why a lot of organizations are invested in these technologies. As a side comment, we also, to support this development, we also, together with UKPN, we also put together a website supported by Everose and Evie Consult. We put together a website called V2G Hub. It's basically a dynamic database of the vehicle-to-grid projects around the world, supposed to offer insights also on those projects and allow a more dynamic analysis of what's going on around the world for vehicle-to-grid. So I strongly encourage everybody to have a look. If you are starting a vehicle-to-grid project, or you have a project that is not logged in, please do get in touch, because this is only useful if it's community contributed. So moving on to learnings. First of all, we've had already different learnings. The projects are bound to finish by 2021, but we already can see some key learnings. First of all, basically, the trials are run on commercial basis, and what the participants are essentially customers. Essentially, they're operated on a commercial basis. You need to set up a contract with the customers, and you need to convince them with a business case or with a convincing customer proposition. And the first thing to notice is that customers want different things or are worried about different things. If you go to private customer, they are oftentimes early adopter in this particular case. They want to understand technology, but they want reassurances about availability of their vehicle, battery degradation, and potential cost revenues. Once their fleet customers are more focused on the impacts on their operation, and they want a solid business case. Talking about, this is particularly true for private customers. You can have a range of options that you can, in which you can build your own vehicle-to-grid proposition. And in terms of how much hands-on you want the customers to be, how much visibility you want to give for your operation to customers, you can go all the way down to giving full visibility of what the energy flows are and what the money flows are. So essentially, the idea behind vehicle-to-grid is that if you provide your vehicle for grid use, you get compensated for that. Now, you can give the customer full visibility of that, or you can span to the other side of the spectrum, in which is completely hands-off. Somebody takes care of all your charging process and your vehicle-to-grid operation, and you don't get the granularity of seeing exactly what's happening at each point in time. But you have, on the other side, you have the reassurance that, for example, everything is bundled in a single monthly figure, and in a way that is the only thing that is visible to the customer. The rest of it is a transparent operation. Again, another learning that we had from one of the feasibility study is that at the moment, today, with the smart devices that you can put in the home, today, smart energy devices, and these range from smart boiler to solar panel to batteries, vehicle-to-grid charger. Essentially, all of these devices to date are optimized to actually work to optimize the energy consumption alone. Essentially, each of one of these devices, if you take a Tesla Powerwall, for example, that is designed to optimize the energy consumption in the house. But when you start putting the Tesla Powerwall together with a solar panel with a vehicle-to-grid charger, making them work together is really complicated because each one tends to optimize all the overall consumption of the same environment. So they tend to overcompensate with each other. So it's still an issue which needs to be, the coordination is still an issue and needs to be addressed if you want to have a home with all smart energy devices. Other thing to consider, the vehicle-to-grid business case works, but it doesn't work for every type of user. So you need to select which user you're going to target. It needs to be a user that has a high plug-in rate, as a high period in which the user stays can be connected to the charger, therefore can be accessible from the grid. In that case, basically compared to a user that has basically very low plug-in rate, the revenues from vehicle-to-grid quadruple, and this is a study from Element Energy, it's led from Element Energy. This comes from the vehicle-to-grid Britain project, which, by the way, the report is freely available online. Again, and I mentioned that you will have, what I mentioned before, that we can have system-wide advantages of 3.5 billion a year by 2040. That actually, I mentioned that there was a caveat to that. Not all of these services are actually accessible from the customer. So when you do the modeling from an overall system perspective, you can consider all the different aspects in which you can say, for example, you can maximize the renewable utilization, you can rely more on DSO services. However, in some of these cases, it's not clear who will benefit from the services and how to quantify, and not even if all of these services are accessible on the market. The simple example of that is if you maximize the renewable utilization, the savings that come from using more wind, say, than coal power, not necessarily are sifted down through the market to the final. All of the savings are not necessarily sifted down to the final user. Again, other key learning: hardware supply and costs are still a constraint. So on the hardware, since we started the program, when we started the program in 2018, the only few vehicle-to-grid chargers that were available were around £10,000 each. Already now they are less than £6,000, the chargers that are being installed in the projects. And this is a projection from, again, the vehicle-to-grid Britain study. And they show that actually they're going down to around £1,000 by 2030. That basically means that this makes it more sustainable and definitely can make the business case profitable, particularly in case you live in an area of high congestion. Therefore, you have a high potential for revenues. Talking about, though, I mean, I mentioned that there were been some hiccups and some, I won't call them drawbacks, but some things that we learned along the way that potentially hinder the current deployment of vehicle-to-grid, even though most of them are being addressed. One feedback that we saw from the project is that basically at the moment you can only do vehicle-to-grid by using the CHAdeMO protocol. And the main passenger vehicle that supports that is the Nissan Leaf. However, when you go out to customer, particularly private customer, not all of them want to own a Nissan Leaf. Maybe they're interested in other characteristics of the vehicle, maybe they need a bigger vehicle or they want a smaller vehicle. But at the moment, that limitation in choice, it basically can hinder the development or the deployment of vehicle-to-grid commercially. However, the upside to that is basically that, and here I put that the roadmap for the charging for the 15.11.8 support. At the moment, we are talking about CHAdeMO. CHAdeMO is the only one that can deploy vehicle-to-grid, can be applicable for vehicle-to-grid as a charging standard. However, the 15.11.8, which is the standard behind the CCS protocol, is the draft standard. The standard will be finalized, I think, this year. But the interesting thing is that basically once the standard is finalized, the CCS, the car manufacturer that supports CCS will come out with vehicles that support vehicle-to-grid operation. That's why I put this roadmap actually come from Charin, which is the association basically behind the CCS standard, and part of the association are also major OEM, and they themselves see as part of this roadmap going to 2025, having vehicle-to-grid, what they call level 4, having that kind of functionality embedded into their vehicle. So in summary, at the moment, the amount of vehicles that you can use for vehicle-to-grid is very limited. The choice of vehicle is very limited, but this is going to be improving greatly once the CCS vehicles come with support for vehicle-to-grid, and this is coming around 2020, 2025. Other problem that has been reported by a lot of our projects essentially is the connection process. UKPN and Evie will talk more about that later, but essentially at the moment, as an overarching feedback that we received is that the connection process is still too long and complicated. And the other problem with that is normally the installation costs are not necessarily known beforehand. So before you do a site survey, it's very difficult to estimate the connection cost. This bears a burden on the business model, because to get to the level of doing a survey, you need to get to with a sufficiently enticing proposition to the customer that you have that initial discussion that leads you to the survey, and at that point, basically, you can basically estimate the real cost. However, to build up that original proposition to the customer, if you have no indication of what the costs are, that's really difficult to get to the second stage of and actually refine that proposal. But I know that DSOs are doing quite a bit in this regard. So probably we'll hear something about this later from Evie as well. The other thing, and I thought of putting this as a call out to Ofgem, which are supporting us in this event today. A recent targeted charging review from Ofgem basically redefined how the levies are basically the residual, what they call the residual charges are levied from all households and businesses. What this means essentially is that, to my understanding, I'll probably be corrected later from Ofgem, but to my understanding, what this means is basically that instead of being the network charges, the residual network charges, instead of being related to the energy consumptions, those are related to basically the connection itself. They are separated from the amount of power that is consumed from the grid. Of course, if you're using vehicle-to-grid, particularly in vehicle-to-home applications, that basically means you're using the battery in the car to reduce your energy consumption. Therefore, you're not taking full advantages because you still have a separate voice that is the network charges. However, Ofgem itself has recognized that there needs to be a more straightforward way to address the flexibility and how flexibility is compensated, and they're doing that with their access and forward-looking charges review. I think it's going to come in a couple of years, but we'll hear later from Ofgem on what their plans are and how that can be contributed to. Finally, one thing that I wanted just to point out that vehicle-to-grid development pace is picking up. So there are more and more projects popping up on vehicle-to-grid. The interest is a lot. It's growing quite considerably. I've recently heard, for example, Porsche and BMW start to work on vehicle-to-grid as well. Other major car manufacturers are still supporting innovation programs targeting and at least experimenting with vehicle-to-grid. And also in the news, it's quite a hot topic from what was in news regarding Volkswagen, but trials with school buses in the US, and so on and so forth. So essentially, it's quite an enticing proposition, particularly if you have vehicles that have a longer period in which they sit idle. The only word of warning from my point of view, I mean, I'm an enthusiast about vehicle-to-grid, and I think it's a fantastic idea. The only word of caution and warning is that vehicle-to-grid is not a silver bullet. It's not going to is not going to generate thousands of pounds or thousands of dollars in profit for each single individual that connect the car. It will have a reward, but it's not a quick gain mechanism that basically solves all the problem of the power grid or generates a new income for the necessarily for the private user that performs vehicle to grid. Another point that I wanted to make is regarding smart charging. So if we're talking about vehicle to grid, it might seem strange because it seems like a step backward. However, I do consider smart charging to be a stepping stone towards vehicle to grid. Particularly in the UK, there has been recently a consultation from OLEV and a plan for a two-step plan, a two-phases plan to get to the point of mandating smart charging. I think that smart charging in itself is important because can represent a vehicle to change user behavior. The interesting thing about smart charging is that once that is mandated and becomes the norm, it shifts the behavior of customers from I plug when I need to charge to I plug as soon as I get near a charging point. And that is a model shift that is really important for vehicle to grid, because vehicle to grid is based on availability of service. So the moment that users starts to become used to the fact that they can just plug as soon as possible, then that becomes an advantage also for vehicle to grid application, because customers don't need to be convinced that somebody else is taking care of the charging process for them. And as we can see here, this is a graph taken from electric vehicle agile tariff from Octopus Energy. And essentially what this shows is just that some people might be doubters that even if you want to implement smart charging, people will actually change their behavior. But actually this is just to say that people actually do change their behavior. The agile tariff is nothing else than a time of usage tariff. And this graph basically shows what users were doing before basically being on the agile tariff, on the time of usage tariff, and then what happens when after they are on the agile on the time of usage tariff. Essentially, what the tariff does, the price is higher in the evening when everybody normally comes on and basically consumes more energy, and lower in the night. And actually, people do try to do follow or tail the lower price. So it does work, and it does have a customer reception. Other things that are we're seeing more and more, and potentially could spark some ideas for collaborations. We're definitely looking at that in terms of future innovation areas. Basically, DSO services. But not only DSO services, some of them basically focus on still on the embryonic stage and focus on frequency regulation on behind the meter services. In any case, I've targeted at congestion management. However, there are other areas, probably more advanced or more a refiner of the refining of the above, that basically can still be explored. For example, batteries, and as such, even the batteries in the vehicles, have a great potential for provision of power quality compensation, or they can compensate for phase imbalance or for reactive power, or simply act as the voltage control, particularly networks that are very weak, and in particularly rural areas where you are at the end of the feeder. Similar things. At the moment, DNOs have a limited visibility of their own distribution network, which is not that is often not on real time. With smart metering, this is improving. But essentially, if you have a charger that embeds vehicle-to-grid facilities, smart charging of vehicle-to-grid facilities or capabilities, essentially that in itself is a meter, because it gives you real-time feedback of what's happening with the vehicle, and you can use that to look at to basically map what's happening on the grid. Essentially, build a real-time map. So I wanted to mention also another thing that might be of interest to you all. BEIS recently launched a smart meter EV charging trial. Without reading all the slide, you will have the slide with you. But essentially, this is an SBRI competition, so it's an innovation procurement, which I believe ends on the 15th of May. but essentially it's for integrating the smart charge point with a smart meter and achieve the operation, the smart operation through DCC, and basically build a SMETS compatible smart charger. I included the link in the slide so you can look for more information. So conclusion. Interest in vehicle-to-grid is growing. So vehicle-to-grid popularity is growing, and fueled by government programs, private initiative, and customer attention to the topic. There are still some issues to resolve. Not everything is being ironed out quite yet. However, I want to point out that already we've seen a lot of positives out of our programs. For example, we implemented the first vehicle-to-grid UK manufacturer vehicle-to-grid charger from Indra, which, by the way, is looking for collaboration. So if you're interested, I can put you in touch as well. We're seeing first customer proposition, first business proposition going to real customers. First installation going into fleets in real-world environments, so not in an enclosed sort of lab in which all the variables can be controlled. So I think it's quite a good learnings. There's still some work to do though. The main learnings that we have first that are basically in 5 categories essentially. So we need to find the right customers, the right services. So it is not vehicle-to-grid is not a silver bullet for everyone in every condition. You need to choose who you're targeting and in which condition. The hardware cost, and I mentioned the charger. Indra is not the only one building vehicle-to-grid chargers. I mean, EO Charging is doing the same. I know that Nissan developed their own chargers. Some of the chargers are coming from either from Netherlands, from Japan. But essentially, we've seen a lot more. I mean, compared to the beginning, I mentioned before that when we started this program, we had 2 or 3 chargers available at £10,000 each. The last event that we had at Select LCV, we had a booth with most of the charger, and we had, I think, over 8 or 9 charging manufacturer on the same booth supporting vehicle-to-grid. So essentially, it is growing. There is a growing interest. The reducing hardware cost is something that will naturally come with scale. We need to understand, and this is probably a little bit across policy and industry, we need to understand how to distribute the value of the whole system benefits across the whole value chain. And finally, I stress this once again, working together and trying to sync the effort is part of paramount importance. Particularly for vehicle-to-grids, there are 2 sectors like the automotive and energy sector that need to integrate with each other. Not only they need to integrate with each other, but the value chain is composed of several actors. So you need to have all these actors together to make vehicle-to-grid a reality. And in this regard, trying to sync the effort and to reach a similar level of understanding of building a community around vehicle-to-grid is crucial. And that's why we implemented a website like the Vehicle-to-Grid Hub. And that's all from me. Thank you very much.
So thank you very much, Marco. That was really interesting, really good. So for the next presentation, we're going to get UKPN. We've got 2 people from UKPN, Neil Madgwick, Head of Connections and Service Delivery, and Evie, Trolove, who's Innovation Project Lead, and they're going to take us through what they're doing regarding vehicle-to-grid connections.
Good. Thank you very much, Simon, and thank you to allowing us to present at this forum. So I'm going to take you through just a few introductory slides about UKPN and where we are at a strategy level, and then Evie is going to dive into the detail. We've only got 20 minutes, so I'll keep this short and snappy, and then of course I'm happy to take questions at the end of the session. So yes, I head up our connections team within UK Power Networks, and I'm also responsible for ensuring that we maximise the number of electric vehicle charging points that we get onto our network to support the uptake of electric vehicles. So there we go. So just a bit about us very quickly for those uninitiated on this webinar. So we are one of the DNOs in the UK. We have about 8.3 million customers connected to our networks, so circa a third of the country. It's about 3,300 public EV charge points connected to our network, and our peak demand, as you can see there, about 16 gigawatts. There are actually about 170,000 generators connected locally to our network. So a really exciting time that gives us that fantastic opportunity to utilize different services from customers who are connected to our network. As Marco talked about, the electricity network is certainly changing. So this slide, and you're wondering why I'm showing you a lovely picture of the London sky landscape. So we used to talk about the challenges of charging at a small level, and we used to talk about 50 kilowatt rapid chargers being about the equivalent of somebody building a block of 22 flats on the street, and the challenges and opportunities that presented to us. But now actually we're looking at something very different in a number of cases. So on this skyline here, we've recently connected two of the buildings, the Scalpel and the glamorously titled Can of Ham. And you can see that those buildings are taking a power demand of roughly 2 megawatts. That's also the equivalent to a small town typically as well. So what you'd expect from these types of buildings, but a significant challenge nonetheless to get the power to those buildings. It would be to a small town. And what we're now beginning to see from EV charging is something very similar. So on the left of the slide here, this is a forecourt, a traditional forecourt, in this case a Shell forecourt, who would have a small modest power supply to supply the shop, normally of around 20 kilowatts. What we're actually seeing now in the new world is forecourt retailers like Shell coming to us asking for similar power requirements to those of the Scalpel, the Can of Ham, or indeed a small town, as they look to put, in this case, rapid and ultra rapid chargers in to their forecourts. So this of course presents a challenge to us, but also a fantastic opportunity, because if those chargers have the ability in the future to provide us other services, vehicle to grid services, it's going to give us a significant resource to pull upon. So our EV strategy needs to take account of this dynamic environment. So from something as small as a street lighting charger pulling 3 kilowatts, all the way through to the challenge of those large EV hubs. So we need to make sure that to run our network as efficiently and effectively as possible, and to enable that decarbonisation of transport, that we have the right tools, the right network in the right place at the right time to meet customer demands, but make sure that we keep energy bills as low as possible while we deliver that challenge. So we look at it in 4 ways. The first area, and Marco alluded to the national grid future energy scenarios, is to have a great forecast of not only where we expect to see the EV uptake, but where and how that will manifest itself as load on our network. And I'll talk a bit more about that on our next slide. So we've developed very detailed, very granular forecasts to help us. The next stage, and again, Marco alluded to it, it's not always easy for us to see where the load is on our network, and importantly, how and when it's being used. So we're investing significant amounts of money on our low voltage network to make it easier for us to understand where that load's being used and how it's being used. And smart charging indeed will play a part in that as well. Then, where traditionally, if we'd needed to provide more power to customers, we would have reached for the shovel to dig holes, lay cable, and build transformers and substations. Our approach now is always to look at the flexibility approach first. So how can smart charging, how can vehicle to grid, how can commercial and technical solutions support us in meeting that challenge before we invest in new cables and transformers? So then, of course, we need to invest strategically where needed, just in time to manage this rise in not only actually the electrification of transport, but the electrification of heat, which is coming swiftly behind. So here's an example of what we call our distribution future energy scenarios. So here on the left, so there are about 8.5 million cars on our network. And what we see is the high scenario to meet net zero, taking account of the latest government consultation to pull forward the ban of petrol and diesel vehicles and hybrids. We expect to see by 2030 around about 4.2 million EVs. If you think at the moment we're somewhere around 120,000, that's a significant increase. So we need to know and need to understand when that hockey stick is going to take effect and when we're going to see that significant uptick in vehicles. So we have invested a lot of time working with Element Energy to develop forecasts down to lower super output area. So that's the geographic boundaries that local authorities use, down to about 400 to 1,200 homes, to understand where we're going to see cars, vans, and other vehicles at a very, very, very local level on our network. And you can see that building out on the map on the right. The next step for us is to turn that into our strategic load forecasting model to understand not only how many vehicles there will be, but of course what type of vehicles and how those vehicles will be charged, to understand what impact that will have on our local network. So I will now hand over the reins to Evie to take you through the detail of what we're doing.
Brilliant, thanks Neil. Hopefully everyone can hear me okay. Cool, so what I'm going to go through now is a little bit more detail on the deploy smart, deploy smart and what different new innovative tools we've come up with to help us optimize the use of existing network capacity to keep costs low for customers and enable that transition to net zero in the most cost effective way possible. So we break this into three different sort of areas, and the first of those is commercial solutions. So this includes electric vehicle flexibility, novel ways that we can enable connections to customers, and V2G and smart charging fall into that category. We've then got the enablers, and these are innovation projects and things that help underpin our forecasting and monitoring tools. And then finally on the right, you've got technical solutions, so things like new equipment or new ways to operate the network using power electronics to more actively manage load and demand on the distribution network. So that gives you an overview of where V2G fits in for us. So vehicle grid is obviously a new technology. It's very exciting for the networks for several reasons. One is that, as Marco mentioned earlier, it enables the potential for new flexibility services. So ways for networks to better use that capacity and also unlock value to customers. The other one is that it's a new technology, so we also need to understand how it operates on our network. So to address those 2 points, we have joined together with a number of parties who are involved in the Innovate UK funded V2G projects shown on the screen. And we're working with industry to understand how V2G works across different customer segments. So we've got Buster Grid and E4Future, which are looking at commercial fleets, Power Loop and Scarius, which are focused more on residential off-street customers, and then V2Street, which was looking at opportunities for V2G through on-street public charging infrastructure. So to go into a little bit more detail on the services that we're looking at through these trials, things that we're exploring are flexibility procurement at low voltage level, which is similar to our HV flexibility procurement, where we would contract for turn down over a specific window that aligns with peak network constraints. and also time of use, distribution use of system charge, which is how we recover our costs as a network, plus an export fee to incentivize V2G assets to export to the network in order to support the wider network. And so through Transpower, we're involved in these projects, and this is helping us get a better understanding of how V2G works and ensure that we are ready as a business for when it transitions from being an innovation and new technology into something that's more business as usual and more widely rolled out. So before we move on to V2G connections specifically, I wanted to take you through some of the things that are available for just traditional electric vehicles. So we have electric vehicle policy. This includes things like EDS 085050, which some of you might be familiar with, but it's our engineering design standards for electric vehicle connections. We also have electric vehicle heat maps, which provide like a red, amber, green indication of headroom available on the network so that you can understand where the network might be constrained and opportunities for connections and how constrained particular areas of the network may be. And in addition to that, we also offer a service where you can book some face-to-face time, or at the moment, probably calls and discussions with experts in the company to better understand where you might be looking to connect to the network and your needs. So V2G, I'm sure most of you are familiar with V2G, but just in case you're not, V2G adds a different sort of layer on top of the existing requirements for EV connections. So because it is a demand drawing device as well as a generating device in network terms, it needs to comply with multiple standards above and beyond just a regular EV. So this is important that it meets these standards for safe and efficient operation of the energy system. And at the moment, the two standards that it needs to meet are the load assessment, as per normal EVs, and also a generation assessment, which is similar to the process that you would have to go through for solar. And that's also known as G98 or G99. Those processes also vary depending on the size of the installation. So there are a number of different forms, and they increase in complexity as you increase in size. So with the smaller connections, the requirements are less onerous, and they increase in as you go up through different capacities that are connecting. But in summary, for vertical to grid, if you're new to this process, or even to some of those who are not new, it can be quite complicated to find the forms, and what we've established over the last few months is a specific V2G website, which enables you to easily find the appropriate forms that you need to fill in and provides that guidance very clearly on our website. As well as doing that externally, what we've also done internally is identified V2G experts in each of our license areas and connections teams. And the purpose of that is to try and upskill internally our understanding of how to assess these connections and make sure that there's consistency across all of our license areas. Another thing that we've been trying is providing simple checklists to try and communicate what's required with the project teams up front, nice and clearly, so that when an application is submitted to the connections team, we know that it ticks all the boxes and all the information is included in one place, which leads to faster and more straightforward connections. So as well as those things, we also acknowledge that there's more changes to make, and part of the Transpower project is ensuring that we develop fit-for-purpose processes for V2G to make sure that the industry can benefit from the technology in the most straightforward way possible. So what we are also looking at doing is we've been working on drafting a single connections form, which would integrate the requirements for V2G and G98 or G99 into the same form that is currently used for EVs and heat pumps. And we're trying to standardize that process across all distribution network operators, so that if you're a customer and you operate in multiple areas, there will be one straightforward process. So that would make it simpler, less paperwork, and provide a better customer journey. As well as that, we're also looking at ways that we can improve the customer journey through things like digitisation or continuing to improve guidance that's available on our website. And then finally, through the projects, we are using the data that's been collected to improve our understanding of how V2G assets operate on the network, and then use data to replace our assumptions on how they interact with the network, so that we can develop more appropriate network planning tools, and as a result offer more better connections to the network. So through the projects that we've been involved in, there are a number of areas that generally come up as questions or things that people are unsure about. So I summarised some of these on the slide, and I won't go through all of them, but if you do see something you're interested in, take a look at it. And if it's not there, then feel free to ask questions later on. But I think this is an area that we're looking to try and make more visible, help the industry in understanding each of these areas. So understanding what charge point certification is required, understanding what is required if you do need to export limit because the grid capacity isn't available, understanding when we need to implement witness testing, export NPAN costs, and then also exploring on-street and AC V2G guidance. It's also worth acknowledging that through the Innovate UK V2G cohort, there is a huge amount of expertise that has been developed through those trials. And what we would really encourage you to do is, in addition to any of the areas that you've already seen, if you've got learnings or you've got suggestions, please get in touch with us and share those learnings or share those recommendations with us, because we want to continue to improve these processes as much as possible, and we're continuing to do so through the TransPower project. So finally, I thought there'd be another couple of resources that I would point out, particularly for the people who are involved in the Innovate UK projects who are looking at opportunities for flexibility. There is a website that we have called the Flexibility Hub, and this is where we host all of our LV and HV flexibility tenders and information. But in addition to that, there's also a document that's been published called the Flexibility Roadmap. And in that document, it details what the current services are that are available, and what the network needs are and the technical requirements for those services. And then further down the document, it also expands on what our future network needs may be and future services that could potentially be provided by vehicle to grid. So it's really worth having a look in there and just identifying some of the areas. And again, we'd love to get your feedback if you think there are challenges in providing those services or other things that you would like to see in there for the next revision. We've also got the innovation website. So while today's focus has been more on vehicle to grid, a lot of the other things that sit under the enablers, commercial solutions or technical solutions that I mentioned earlier and Deploy Smart are available to look at on the innovation site. So this is a database of all of our innovation work that's either been delivered previously or is ongoing, with project scopes and links to more information. So things like our smart charging project called Shift is available on there, as well as more information about TransPower. And then finally, we've already seen a bit of a preview of the V2G hub, but just another point to encourage you to have a look at that. We're looking at how we can make improvements to that too, and we'd like to keep that as live as possible with as many projects being delivered. So I encourage you to have a look, and if your project's not already on there, then please do register it. That was all from me, so I think we're bang on time. If there are any questions, feel free to ask them.
So thank you very much to Marco, to Evie and to Neil. That was really, really interesting stuff. And we've got a number of questions that have come through. So we're going to start with, we'll start with Marco. So the first question we have is regarding, from Paul Gamble, and it's, does the projected cost of the charger include connection to the grid, or is it hardware only?
No, the one that I showed is hardware only. connection is tricky, as we have seen. Basically, when I mention £1,000 by 2030, that is intended for it's a 7 kilowatt charger in domestic application, but it's just the charger. Keep in mind, for reference, that if you take a smart charger today, prices before the grant range already from I think you can go down to 400 quid, but they go up to £1,000 already. So if you go for the top of the line, so that's just the charger. It doesn't include the installation cost.
Okay, thank you very much. So another question for you from EcoCar. Any possibilities of V2G with a Type 2 connector?
Yes, we mentioned it was mentioned by Evie on her presentation. Basically, the V2 Street projects, they did try the AC vehicle to grid. They successfully demonstrated it. The only issue at the moment with AC vehicle to grid, there are some companies like Honda or Renault trialing that with their vehicles. But while the Nissan Leaf is available commercially with CHAdeMO, with AC vehicle to grid, they are still at the stage of prototypes. Keep in mind, though, that the situation is potentially changing very rapidly, because I mentioned a standard, the 15.11.8. The second version, which includes the use case for vehicle to grid, was supposed to be ratified last year, probably will be this year, but that includes AC vehicle to grid, well, vehicle to grid in general, both AC and DC use cases. That basically means that when the standard is ready and is finalized, that it's easier for manufacturers, both of charge point and vehicles, to actually come up with product that basically allow you to do AC vehicle to grid.
Okay, thank you very much, Marco. So just to mix it up for UKPN, so are there going to be any specific V2G grid codes, or are we going to continue to use the solar guidelines? So I don't know, one of you could take that, please.
Yeah, so I'll take that one. At the moment, we're not planning to use or implement any new codes. The current standards that are required to meet are relatively or technology agnostic. So where possible, we will apply existing standards to V2G. But I think what we're looking to learn through the projects, and particularly implementing some of these larger scale V2G projects, is understanding if there are any restrictions or any challenges in meeting those. And then we would explore whether there's a need for exemptions, which is the case for other battery storage devices. Neil, do you have anything to add to that?
Yeah, no, I think you're correct on Evie. Look, we've got the current standards that say connect and managed 3.68 kilowatts. There's no plan to change that at the moment. But as we get more real data from the chargers, from smart meters, and from our LV network, you know, these things are always under review. But as you rightly say, Evie, at the moment, the current standards are the ones that we continue to intend to apply. Agreed.
Thank you, guys. So another question for UKPN. So DSOs might not be content on price signals to protect their network. Is that accurate?
Well, I think, look, we've seen, and I'm sure many of you are aware of the current proposed change by National Grid on the grid code to disconnect generators in an emergency because of COVID-19. So look, there are always going to be situations in which we need to, as UK PLC, protect the network. So our view is absolutely flexibility, commercial contracts, technical solutions first, and we think that will those will cover off the lion's share of what we need to do, as well as our traditional, you know, investment plans to make us fit for the future. But you always, you know, we have a responsibility to keep the lights on, and so if there are other solutions that are needed on top of commercial and technical contracts, then of course we need to keep those options open.
Okay. Thank you.
I just add to that sorry, the two signals or the two mechanisms that I briefly explained on the page, the flexibility procurement and the time of use draw plus export, that kind of takes a two-pronged approach. So one is more price signal driven and the other one is more contracted. So again, we're likely to get quite different levels of response and reliability from those two different services. So it's something that we're continuing to explore through the project, both for V2G through Transpower and for smart charging through the Shift project.
Thank you very much for both your answers there. So if we go back to you, Marco, so this is a question from Niall Riddle. I would be interested in your views on whether the future of V2G is more likely to reside in DC solutions or AC solutions, noting that the V2G real-world demos includes examples of both.
So I've seen a couple of questions in that regard. Honestly speaking, I think there will be room for both. If I had to make a wild guess, I would say, at least in the longer run, I would see more opportunity for the AC vehicle to grid in fleets and in on-street solution. At home, as a paradox, I would see more and more things going DC, for the simple reason that if you look at what's happening in terms of energy networks, essentially you're configuring the smart home as a DC, as a microgrid, on which most of the devices, the smart home devices, are already in DC. I think there will be space for both. It really depends on which kind of vehicle are we talking about. I mentioned that AC vehicle to grid is still a prototype phase, pretty much. Of course, it's easier to, how should I say, I think that the problems are different. For one of the things that was mentioned also in Evie's presentation, if you have an AC vehicle to grid, then you have an inverter and there's characteristics that is mobile. So it becomes more a matter of how do you certify that. For example, if you take Renault, they are splitting some of the control between the charger and the car, so that in a way you achieve certification like this. But there are some different issues to solve. Of course, if you start from small scale ad hoc built vehicles, like, I don't know, commercial vehicles, it's easier to get those sorted, because now when you design the whole system altogether, it's not meant to be compliant with all the chargers out there. From a passenger vehicle point of view, there will be a space for AC vehicle to grid, particularly in countries that already have an extensive public network. I'm thinking, for example, Netherlands. They've already a smart-enabled public network, and they're trying to find a way to reuse it also for vehicle to grid. If we're talking at home, I honestly see that now going towards DC, particularly if the price of chargers decreases quite a bit, and particularly if you're using other smart home devices. It doesn't make any sense to have multiple inverter in the house when you can have just one and optimize everything with a single inverter. It's not going to come now. It's not going to come in the next year or two, this scenario, but I have no doubt that that's where we're headed.
Great, thank you, Marco. Well, yeah, there's a few more questions for you. So, are all the Nissan Leaf versions, so the 24, the 40, and the 60 kilowatt hour vehicles, are they all capable of vehicle to grid?
So basically, yes. So certainly the 40 and 60 are capable of vehicle to grid. The 24, it is still. I think that there was a version that there were two versions with 24. The second version is compatible with vehicle to grid, not the first one, if I'm not mistaken. I mean, don't quote me on that. But I know that some of the 24, there are some more specific requirements on the 24 kilowatt hour, but some projects are using also cars that are out of warranty, and there were 24 kilowatt hour recently. I think that certainly the 30, the 40, and the 60 are compatible. The second version of the 24 is compatible as well.
Thank you very much. So another question for you, and this is regarding time scales. So any feelings for timescale before wide take up of unsupported by grants or demo projects of vehicle to grid?
I would say realistically, we are talking about probably between 2025 and 2026, 2027. Those are the years that I would see a major take up in vehicle to grid, principally because that's where vehicle manufacturers plan to have their vehicle to grid enabled basically products out there. There is to say that is the caveat to that is basically how strongly governments will push on vehicle to grid that smart technologies to actually come out in the market. For example, if you decide in some European countries they're thinking of mandating the CCS that comes with 15.11.8, and even that is simply mandated for the smart charging side of it, it's foreseeable that if you have to implement a protocol that basically deals with how you allocate the charge, how you negotiate the charging session and all of that, that can be easily extended to vehicle to grid. So in terms of availability of vehicles, I would say probably around 2025, that's where I would see the take up in vehicle to grid technologies. On a fleet level is slightly different. I'm talking about passenger car here, but on a fleet level is slightly different because fleets are moving at a different pace. They are pushed by not necessarily their reward as private customers can be. There might be a different driver that is their sustainability. And they normally have a higher say, particularly if you use ad hoc built vehicles, they have a higher say on what specification the vehicles can have. So probably I would see fleets coming in earlier than passenger vehicles.
Thank you very much for that detailed answer, Marco. So we've got a question for UKPN. Now, this is regarding standardisation of your process, I believe. So the question is from Paige Mullen, what is the timeline to start to roll these out across the UK to standardise with other DNOs or put out for consultation? So I understand that might not be an easy question to answer.
Yeah, sure. So the first draft has been shared with the other networks, and so we're working at the moment with the other DNOs to make sure that it meets all of their requirements and our requirements, and try and align things as much as possible. We haven't got a fixed timeline to work to in order to get that out, but we're looking to progress that as quickly as possible, so that where possible, the V2G projects who are still doing connections applications will be able to utilise that. But there's no fixed timeline as such yet.
Thank you very much. Another question for you guys from Ian Bine. Is the LSOA forecast data public?
Yes, I'll take this one. Yes, I mean, if you'll get access to the slides, I'm sure afterwards. On the slide that I presented underneath, there was a link to our open data portal, and on that portal you can download every single spreadsheet for every single LSOA and MSOA area, and then on a spreadsheet, and do whatever you wish with that data.
Thank you very much, Neil. Another question for Evie and Neil. How do you see what are the biggest balancing challenges that you're going to face with V2G exports coming in from an already low demand zone?
Yeah, so at the moment, the way the connections process works is that we assess that risk at the point of, or at the time that the connection application is submitted. So we look at what other generation is in that area, what the demand is, and make an informed assessment about the risk associated with adding additional generation to that area. As we go forward, like I said, by collecting data on how the V2G assets actually respond to different price signals or flexibility markets, or are used without any of those, or just used by customers how they wish to meet their own needs, we will then be able to place some of our assumptions about how they work to more accurately assess the impact on the network and try and make sure that connections are adequately sized and that we can connect as much generation from V2G as possible within safe operating limits of the network. We're also developing, we'll also use the outputs of the project to feed into more forecasting tools, which will enable us to look at what the opportunity is if we turn on and off different flexibility services. So looking at growth on the network from EVs, and then looking at how the network is impacted if X% of those are smart charging devices or V2G, so that we can better understand which areas of the network might need more support, either from V2G or other sources of flexibility.
Thank you very much for that. So this could, I think, potentially go to Marco or Evie or Neil. So National Grid have said only 5% of the total UK EV fleet is currently smart charging V1G. By 2030, what do you think a realistic split of V2G, V1G and unmanaged dumb charging across the UK?
Sorry, probably I can make a comment on that. So first of all, is a comment on definition. Definitions are always where the thing that trips us. V1G is not the, well, in the current understanding, V1G and smart charging are two different things. If you look at what the government is thinking about smart charging and what they assume smart charging is, essentially is load deferral. And it's just that, exclusively load referral. V1G, in a way, normally is intended something more interactive, that you have more services that you can provide to the grid. So you can do, for example, down regulation, while that is not considered in the current consultation at all when we talk about smart charging. That said, basically, I assume that considering that their plan will come into action in 2025, if we're talking about 2030, I would assume that more than half of the vehicle could potentially be enabled to be smart. If we are realistic about it, vehicles can already do today, can already defer the charge. So if that is what we intend for V1G, simply smart charging and load deferral, most of the vehicles on the market today, they can do that already. It's just a matter of setting up manually or through the phone. If you do time charging, you can do that with a Tesla, with a Nissan Leaf, with a Jaguar. You can basically already defer when the car starts to charge. Of course, that is not necessarily sufficient, because you need to be integrated into the system to have a continuous communication to understand what's going on in the system and how you can respond to it. And that's where difficulty starts to come in. But if you're simply talking about deferring the load, and that is considered already smart, then basically it can already happen. In terms of widespread, I would say in 2030, probably we're going to have, I would assume roughly half of the vehicles will be able to do smart charging. If you look at the forecast for National Grid, I mean, I put some of that in the presentation. They consider by 2050 that in the lowest scenario, 60% are going to do. I'm going to be enabled to do 60% of the vehicles are going to be smart charged. However, in the highest scenario, is going to be 78%. So I think we're going to see a rapid increase in that. And then, just like with the 80-20 rule, what is going to happen is that you're going to have a higher increase, keeping in mind that people change a car here between 5 to 7 years. They change the car. So you will get the new car with smart enabled feature. What is going to be difficult then is the top end with all the rest of the vehicles that are not necessarily passenger vehicle, because in that case, it's a little bit more difficult to embed smart.
All right, thanks, Marco. And just I think kind of like building on that question, there was a question of actually should more work, should all our eggs be put into developing those, well, the V1G services before, instead of getting ahead of ourselves, is the way the question was phrased.
Yes and no. In a way, how should I say, V2G, it's an addition on top, bolted on top of that. We went for our competition for vehicle to grid because there were already in 2017 products that could achieve smart charging by deferring the load. I see the problem in two ways. From a technical point of view, I mean, most of our projects that achieve vehicle to grid, you can easily use that to do just one directional services. I mentioned that we are trying to target advanced services, but that needs to go in sync, for example, with what's happening at DSO level, what's happening at national grid level, what's happening with the local energy systems. So from the technical point of view. From the policy point of view, I think that probably more work probably is needed. And I would encourage everybody to respond to consultation, to participate to task forces, simply because those are the setting in which the direction of what's happening in terms of smartening the charge of vehicles is get taken. So if the direction, for example, one of the prevailing voices, and that's what the base competition that I mentioned was targeting, is how to use, can we do smart charging by using the DCC protocol and the SMET protocol to use basically to do load deferral. In my opinion, for example, that can be potentially a limiting factor when you want to pass from load deferral to services. But it's something that needs to be explored more from a policy point of view. From a technical point of view, it's already possible to do smart charging.
Okay, thank you, Marco, for that. So we've got time for, I think, 2 more questions, and they're both for you, Marco.
All right.
So the first question is about grid battery storage, essentially, versus V2G. So what do you think the impact of V2G will be on grid battery storage? Will it potentially replace standalone battery storage?
I don't think that vehicle to grid will replace battery storage. So vehicle to grid is what I call an opportunity technology. So you have an asset that you paid for. It's an expensive asset. You paid for that already, and normally sits unused for most of the time. Normally, more than 80% of the time, the car sits unused and could be plugged into the grid. Of course, if your target is to do energy trading, so if you want to buy an asset to do energy trading or to participate into the energy market, it makes absolutely no sense to buy a car and basically having to have it plugged into the grid at all times. So I don't think that vehicle to grid is a side technology to battery storage. There are studies that show that actually, if you have a high penetration of vehicle to grid, in a way that enters in competition with battery storage. I don't think that probably that they will just bring the level at a lower level of equilibrium of balance. But I don't think that one will replace the other, simply because people will still continue buying vehicles, and those are batteries that can be their usage can be maximized. But if you're talking about, I want to provide megawatts to the grid or megawatt hour of storage, and you want to do that at an industrial level, probably you're going to be looking at using battery storage.
Thank you, Marco. Evie, maybe you could just add a little bit of colour to that as well, please.
Yeah, I think the other thing to add to that is the difference between addressing imbalances and addressing local network constraints. So I think the real advantage for V2G is that it's generally, well, for residential anyway, it would be co-located with where we've got high demand, and potentially offers an opportunity to support at a local network level. So that offers a distinction between the two services as well.
Great, thank you very much. So we've got 1 minute left. So very quickly, Marco, for V2G charger manufacturers, do you think they are held back with only being able to work on products for CHAdeMO at the moment, given that CCS V2G enabled cars are not coming until 2025?
I think that are partially held back. However, I would encourage people to participate in forum. I mean, Ella does a plug fest normally twice a year to check compatibility. You can participate to the standards committee, which the UK is notoriously not very good, at least in this sector, in participating. We are a leader in vehicle to grid, but we are taking the standard development from others. I would encourage everybody to participate into that. There are already companies, including OEMs, working on interim implementation of 15.11.8, which basically can allow the implementation of the standard also from charge point manufacturers. So the development is already possible, and actually I would encourage that, because by the time, keeping in mind that car have a lead cycle, a lead time to get to market that is normally between 4 and 5 years. So what you will see in 2025 are the things that are developed basically right about now. So if you start collaboration process and start basically collaborating and co-developing things, you will get ready by the time those cars are on the market. Otherwise, you will follow what the market leads you. And I can assure you that there are other charge point manufacturers around the world that are already developing their product. They're already readying their product to that extent.
Great. Thank you very much, Marco. And thank you very much to Evie and Neil as well. I think that was really insightful, and there's some great question and answer sessions there. So we're now going to move on to a break, a very short 10-minute break, and then we'll come back, and then we're going to hear from Ofgem about what they're doing within how to decarbonise the market, and we'll also hear a bit more about the TCR. So thanks very much. Bye.
The Global Challenges Research Fund Demonstrate Impact competition has been set up into 2 phases to help resolve some of the world's most challenging problems. And that's wrapped around the Sustainable Development Goals. So these 2 phases are for innovators looking to produce products or services. The first phase is for understanding the cultural context. It's understanding people's needs. It's understanding how your innovation is going to be deployed, and fully understanding the context and the need that you intend to meet. After successful completion of that, you'll then be eligible to then apply for the second phase, where you will have the opportunity to then develop your prototype, your demonstrator. But that's given that you have excellent evidence from the first phase. So in the first phase, we expect to see some excellent human-centered design, working with people, understanding their needs, identifying all the different stakeholders that may be involved in deploying your product or service. After that, we then expect you to have a really good articulation of the problem that you're meeting and why it's necessary. With that good articulation, we're then fully confident that you can then make an excellent solution that would then meet that problem. This organisation links up innovators across the UK and wider to help diffuse innovations out there. Some of the best innovations that exist are the connections between two seemingly disconnected domains. So if these people are never speaking to these people, then an opportunity may not ever arise. So what we do is we try to connect people that otherwise wouldn't have been speaking. If you've got an idea and you want to get it out there, then we can then internally have a bit of a huddle and try and work out who's the most appropriate people for you, who's the best people and who's the most appropriate people for you to commercialize your ideas. We deal with extremely large corporations and we deal with solo entrepreneurs, and they're all at different stages on their innovation journey. And when it comes to impact, that's not just economic impact, it could be social, it could be environmental as well. You know, it doesn't matter how big you are or how far along that journey you are. We want to help you, and we probably know some people or we've got some knowledge that could help you progress on that innovation journey in some way, and that's what we're here for.
Back, and I hope you had a nice break. So now we have the Ofgem presentation. So Stephen Perry, who's Senior Manager for Charging and Access, and Eleanor Wood, Head of Electricity Network Charging, will be taking through what they're doing at Ofgem.
Brilliant. Sorry. So thank you very much for having us today. So I'm Stephen Perry, and I'm joined by Eleanor, one of my colleagues as well. And we'll be talking through a bit of an overview of the work that Ofgem's doing, an introduction to kind of who we are. And then specifically, we'll be looking at some of our reviews of network charging. So we'll be looking at our targeted charging review that I think a number of you have talked about. And Eleanor will be talking through that. And then I'll be providing an overview of our access charging review and some of the wider activities that we're doing to try and support decarbonisation. So for those of you that are sort of less familiar with Ofgem, we are the independent energy regulator for Great Britain, and our statutory duty is to protect the interests of future and existing energy consumers. And we've kind of really focused our work in the last few years around kind of three core objectives that we're trying to achieve. That's enabling competition and innovation, and decarbonising at lowest cost, and protecting consumers, especially those that are vulnerable. And we've got a sort of suite of reforms that we're looking to try and implement. So the energy system is changing. We know there are a number of drivers for these change. So we've got decarbonisation, we've got technological change, and these drivers are having a big impact into where people connect to the network, what they connect to the network, and how they want to use the network. So vehicle to grid and electric vehicles form a key part of these changes that are happening on the energy system. And we want to make sure that our energy regulations keeps pace with these changes and helps deliver those objectives that we identified in the last slide. So we have a suite of reforms that we're focused on implementing to help deliver this. So we've got reforms that are focused on network operators and network companies to make sure that there's the right incentives on them to help facilitate decarbonisation at lowest cost. We're thinking about the framework for system operation and making sure that we're balancing the network in a way that's most efficient. And specifically what we're going to focus on today is our approach to network signals and cost recovery. So these are the incentives and the approach that we take for recovering costs on the network and the signals that they send to users about how and when to use the network. So we have got, so both the work that Eleanor's working on, our targeted charging review, and the work that I work on, our access significant code review, are both focused about trying to create a smarter, more flexible energy system. So there's a really big win for consumers if we can get this right. I think Imperial College put some research together a couple of years ago that sort of talked about the potential benefits for consumers being in the value of between 14 and 50 billion pounds by 2050. So there's a really big potential reward for consumers if we can create this smarter, more flexible system that reduces the need for sort of expensive network reinforcement. So we've really focused on how can we make sure that we're creating these signals for users to be flexible about when and where they use the network. And there's two main mechanisms that we use to do that. So one is around network price signals. So as energy consumers, we all, as part of our energy bills, about 25% of our energy bills are what we call use of system charges. So these are the cost of maintaining the electricity network, and we can design those network prices to send signals to users about where and when they should be using the network. So as part of our access and forward-looking charges review, we're looking at how we can send those right signals to the consumers that accurately reflect the costs and the benefits that they're creating. So if users are creating benefits, how can we send the right signals to users that reflect the value that they're delivering? So that's a really big focus of what we're doing on the access significant code review. Alongside that, we've also been looking at how we can try and minimize distortions in those signals. So that's been the big focus of our targeted charging review that Eleanor will talk a little bit more about in a minute. So really, but those two really kind of work together to send the appropriate price signals to users to be flexible about where and when they use the network. So that's network price signals, and then alongside that, we're doing work on how we can contract for flexibility. So this is how users might be able to sell a service to either their network operator or National Grid as system operator, to be flexible, so to turn down or to turn up their electricity or sell another type of network management service. So we've been looking at how we can broaden out the existing markets that exist to sell those services to. We're looking at how we can create new markets in terms of at the distribution level. We think there's a new market that users could sell flexibility services to. So we're doing a lot of work on that as well, and I'll come on to it a little bit more later in the slide pack. So I'll hand over to Eleanor, because I think this is probably the main part that a lot of you have been focused on, and that's our targeted charging review.
Thanks, Stephen. Great, I think I have control now. So yes, nice to meet everyone. My name's Eleanor Wood. I'm the head of electricity network charging at Ofgem. So I work with Stephen a little bit on the access significant code review, but my main focus for this year is the targeted charging review, which I'll call the TCR from now on, and the implementation of the TCR. So the TCR decision came out last November, and 2020 is really all about the industry process to develop modifications to the various codes that will be used to implement the TCR decision. So I thought before we jump into the review and what it found, we should just do a bit of a lay of the land in terms of the charges that we're talking about and how much money is involved, how the different cost buckets are basically split between different things. So the TCR focuses on the recovery of a subset of network and system charges, being network residual charges and BSUOS charges. So I've coloured those in orange on the slide. And this slide puts those charges into the context of all network use of system and access charges to give you a sense of scale. So the main groups of charges on the slide are then the costs of the transmission network, the cost of the distribution networks, and the cost of balancing the system. The pound figures that are on the slide are a few years old, but the network costs tend to stay basically the same year on year during a price control period, so they should still be fairly accurate. And then BSUOS costs do vary and have actually been increasing over time. So that 1.3 billion is probably a bit out of date. I was having a look this morning, and average BSUOS charges have gone from £2.50 2 years ago to about £3.50 on a running basis right now. So that is a bucket of charges that will vary over time and seems to be trending upwards at the moment. The navy bar shows the split of which users pay these charges between demand and generation. So sticking to BSUOS, you can see it's split 50-50 between generation and demand users at the moment. So every hour, the costs of balancing the system that are incurred by the electricity system operator are split between whoever was either importing or exporting onto the network at that time on a megawatt hour, pounds per megawatt hour basis. But then you can see that for the distribution network, the majority of charges are recovered from demand users. So that's energy customers. And then on the transmission network, some charges are recovered from generation, but more than 80% coming from paid by demand users. So the grey charges are the charges that are in scope for the access SCR that Stephen's going to focus on. And the key difference between the grey and the orange charges is that the grey charges are designed to be cost reflective, as Stephen mentioned, and to send users a signal that they can respond to. What those signals should be and how the charges should be designed is what we're focused on right now in the access SCR. So the TCR, on the other hand, was focused on the orange charges, which we deem as cost recovery charges. You can think of those orange charges as the costs that need to be recovered from the users of the network to keep it running and fund new investments that we can't currently charge in a way that sends a signal to the users of the network. So that's what we mean by a cost recovery charge. The amount of the charges is driven by the underlying costs of the network, and basically the network residuals are the gap between the forward-looking and connection charges and the RIA revenues that the different network companies are allowed to recover. BSUOS charges are the total costs of balancing the system from the ESO, so we'll cover those in a bit more detail later. As you can see from the slide, those charges that were in scope for the TCR are about half the total costs of operating the system, so 4.8 billion, I think, if you add up all of those. Great. Okay, so as I said, the TCR is focused on the network residuals and BSUOS charges. The foundations for the review and the decisions were laid in, I think, since about 2016, really, which is when Ofgem was first instructed to start looking at embedded benefits and also the implications of triad avoidance for network charges and system stability, as well as some other distortions in the charging regime. So the review was launched in August 2017, and we made the decision last year. If we think about the objectives of the review, we really focused on the fact that we can't send a useful signal to network users with these charges that we were focused on. So the aims were to charge users in a way, to reduce harmful distortions in the different markets, and to make changes that were practical and proportionate. So the decision has led to a pretty new, pretty different charging structure for demand users for network residual charges. So starting from April 2022, demand users will be charged fixed charges based on their connection voltage and connection capacity for use of the distribution and transmission network on a pounds per site per day basis. We'll also be removing a number of embedded benefits. So embedded benefits are differences in the incentives or charges and payments facing different types of generation based on where they're connected in the network, but not really based on a difference in the costs and benefits that they provide to the network. So firstly, we'll be setting the transmission generation residual to zero. This is a charge that had actually turned negative in recent years. So generators that are connected to the transmission network will no longer receive that payment. So generators at the transmission level do pay transmission charges based on their location. And then over the past few years, their total charges have exceeded a threshold set in European legislation. But the definition of that threshold is being reworked at the moment by industry, which will likely mean that fewer charges are included in the threshold and we can stop paying that generation residual. The other embedded benefit was charging suppliers for their BSUOS charges, those balancing system charges, based on their gross demand. So generators connected at the distribution level do not pay BSUOS, and that is not going to change through TCR. So in addition to this, though, that generation gets netted off at the moment from a supplier's total demand when a supplier's BSUOS charges are calculated. So at the moment, most suppliers pass on a payment to the generators within their customer base to account for that discount that in their BSUOS charges. So from next April, that will go away and suppliers will start to be charged based on their gross demand. In terms of that other embedded benefit with BSUOS, we set up a second task force to think about full BSUOS reform, looking at who should pay BSUOS and how those charges should be levied. So I'll talk about that a bit more. Okay, so that's the summary of the decision. What drove the decision really is that we think the costs of operating and maintaining the grid will be spread more fairly among those who use it, and that consumers will save about £300 million per year, starting from next year, or about £4 to £5 billion in total. So I thought this group would probably be most interested in the changes to residual charges. So I'll just quickly go through those changes in a little bit more detail, and then we'll move on. So for the transmission generation residual, I won't focus on that one, but it's less relevant for this group, I think. But starting from April next year, we'll be removing that charge so that only demand users are facing a residual charge for use of the transmission network. So that we call the transmission demand residual. Originally in the TCR decision, the changes to the transmission demand residual were going to be implemented in April 2021, but we've had some challenges associated with that. So Ofgem made a decision in March to allow the ESO to withdraw the modification for that change and to delay it by 1 year, basically. So we're looking at April 22 for all the changes to the demand residuals, and until they come in, we'll be in that pre-TCR world that you can see in the third column here. So the main change for the transmission demand residual and distribution residual for large users, sort of non-small business and non-household users, is that charges will no longer be calculated based on usage during the triad period or peak demand periods. So under the TCR, users in those categories will be charged a fixed £1 per site per day charge, depending on which voltage they connect to the network, and a few other characteristics. So if you're a large site, you'll be put into a charging band based on your maximum import capacity. So how big, what's the number of kilowatts or megawatts that you want to be able to import to your site that you've agreed with your DNO, with your distribution network. And then for the distribution residual, a change for small users is that they'll move from a volumetric charge based on how many kilowatt hours they use throughout the year to a fixed charge per site. So all households will be paying the same amount to be using the electricity network for the residual component. They may still face different charges for the forward-looking components, depending on what happens with access. So that's the change to the residuals. And then I'll quickly touch on BSUOS. So I mentioned that all transmission connected generators and also all demand users pay BSUOS on a volumetric basis. So that's £1 per kilowatt hour or per megawatt hour charge that's levied based on costs that were incurred every settlement period. We're making one change through the TCR to charge suppliers based on their gross demand so that they will no longer receive a discount depending on embedded generation within their customer base, but distribution connected generators will continue to not pay BSUOS, and that will start next April. Then we've set up a second task force to look at full BSUOS reform in the context that BSUOS is a cost recovery charge. As I mentioned, all those orange charges, we believe that they can't be levied in a way that sends a useful signal to users. So because of that, the second task force will be using those same TCR principles of fairness, removing distortions, to decide who should pay the SUOS charges and how they should be levied. So that task force is currently on a pause for 3 months just because of the COVID pandemic, but they'll be hopefully starting work again in July, and we're expecting recommendations from that group in September. So I'll hand back to you, Stephen.
Brilliant. So as I was sort of talking about at the start of the presentation, you know, our reforms on the targeted charging review should really be seen as part of a wider package of reforms that we are undertaking. And as Eleanor mentioned, there's two components to those network charging. There's the residual part of network charges that Eleanor's just spoken through, and then there's the what we call the forward-looking. So these are the parts of network charges that are designed to send signals to users about the value that they are creating. So if they're creating benefits, it's this part of the network charges that should be signaling that value back to them. And same with costs. If they're creating costs, it should be this part that signals those costs. So, you know, we launched the Access Significant Code Review in December 2018, and there's 4 main components to the review. The first part is looking at the choice and definition of access rights that are available to users. So by access rights, we mean the rights that users have to import or export electricity onto the network. So these should identify how much they can import or export, when they can import or export, whether they are willing to be curtailed or whether they're willing to be interrupted at certain times. All of these things are part of their access rights. And we think that we're looking at whether we should improve the definition and choice of those access rights that are available. The second part is looking at the distribution connection charging boundary. So when users connect to the network, they pay a connection charge. And at distribution, as part of that connection charge, if a user connects to the network and they trigger some reinforcement on the network, the user pays a proportion of that network reinforcement. So the proportion of network reinforcement that they use, that user pays for. But these arrangements are different to how they work at transmission, where the user doesn't pay for any wider network reinforcement. And a number of users have highlighted that the potential costs associated with this network reinforcement might be a barrier to people connecting to the network. So for some users, these connection charges can be quite high, and there's a concern that might be stopping people being able to connect. So we're looking at whether we should look at that split of charges between the connection customer and wider use of system customers. So that's what we term the distribution connection charging boundary. The third part of the review is a wide-ranging review of the distribution use of system network charges. So it's at the distribution level where we're seeing quite significant changes happening at the energy system in terms of who's connecting to the network and what they're importing, how much they're importing, how much they're exporting. And we wanted to do a wide-ranging review of the signals that were being sent through the distribution network charges to improve the signals that they're being sent. So as part of that, we're thinking around the locational signals that are sent through distribution use of system charges. So at the moment, within each DNO area, so within each distribution area, there aren't any locational signals about or any differences in terms of those network charges, even though that we know that within each distribution area, there are quite significant differences in terms of which parts of the network are constrained and which ones aren't. We're also looking at the balance between how much of the charge is based on the total amount of capacity that users want, and how much of the charge is based on when they use their electricity. So how much we should put a focus on time of use type style charges. So these are all components of what we're looking at through our wide-ranging review of the distribution use of system charges, and they're all focused on trying to improve the signals that are sent to users. We're also looking at specific elements of the transmission network charges. So we aren't seeing as much change at the transmission network, and we've recently, over the last few years, had a number of reviews at transmission, so we aren't doing the wide-ranging review, but we are looking at some aspects of the transmission arrangements. Specifically, we're looking at how demand is charged and the design of those demand charges. We're also looking at how those generators that are connected to the distribution level may be charged or maybe not charged for the impact that they could have at transmission. So it's very specific elements of the transmission review. So those are the four main components that we're looking at as part of the access rights review. And as I said, they're all focused on trying to send better signals to users about how their behaviour can impact the network. And there's three guiding principles that we're using to assess the options for change. So do these options help support more efficient system development? So do they send signals to users that should lead to reduced need for network reinforcement? How do these options reflect energy as an essential service? So specifically thinking about smaller vulnerable customers, how would these changes impact them? And then how practical and proportionate are these changes? And these are the three guiding principles that we're using across all four elements of our review to assess which options to take forward. And I'll skip on to the next slide, actually, because I think this is probably a useful one, just as I've been talking through those different elements of the review. This provides a bit of an illustrative example. And in this one, we're thinking about potentially a delivery company that's wanting to connect up new electric vehicle chargers and provide vehicle-to-grid services. And I sort of step through how the changes that we're doing on the access rights reform could impact a user like this. So from an access rights perspective, having new choices that the user can choose from. Some of these choices might allow the user to connect quicker. They might allow the user to have cheaper connection or cheaper use of system charge. If they're willing to accept a different type of access right. So for example, this delivery company might want to have more access overnight when all of its vans are back at its site and looking to charge up, than it needs during the day when potentially all its vans are out at work. So you could profile the level of access that it has, so it has more access overnight and less access during the day. And that might be cheaper and quicker to connect than having a 24/7 level of access. So secondly, we're looking at I spoke about the connection boundary. If this user wanted to increase their level of capacity that they had, so say they were previously reliant on petrol vehicles and they wanted to convert to electric vehicles and they wanted to install some EV chargers, they need to increase the amount of capacity they had at their site. Under the current arrangements, as I mentioned earlier, they'd have to pay for a proportion of the reinforcement. If we were to make a change to the connection boundary, then actually that would reduce the connection charge that user faced. So they wouldn't face the cost of those reinforcements as part of that connection charge. So that would quite significant potentially reduction in their connection charge. But we signaled we'd only do this if we could send locational signals through our use of system charges. So the current arrangements are very good at sending signals to users about where on the network there's spare capacity. So if we're not doing that through the connection charge, we said we want to improve the locational signals through the use of system charges. So the next bullet touches on that. So if we're looking at increasing the level of locational granularity, looking at the approach to calculating those costs within each of those different locational areas. For a user like this, if it's located in a demand-constrained area, it could receive credits if it's willing to do vehicle to grid and export onto the network during peak periods. So for vehicle to grid, this could be a really useful source of revenue potentially in the future if we're looking at how we calculate some of these locational charges to better reflect what's happening on that specific part of the network. And the fourth part to touch on is the temporal signals, those time of use signals that we're sending to users. So as I mentioned, we're looking at the balance between the signals that are sent through time of use charges and those that are sent through capacity charges. And so if we were to introduce stronger time of use charges, that would send stronger signals to examples like this Evie delivery company to charge their electric vehicles at off-peak times and then export back onto the network at peak times. So this sort of hopefully provides a bit more meaning really in terms of how the charges and the reforms that we're thinking about under our access SCR could impact a user that's looking to do vehicle to grid. And in terms of how we're taking forward our access SCR, so we launched it back in 2018. Last year, we published 2 working papers outlining our initial thinking. And in March of this year, we outlined our shortlisted decisions, so the shortlist of options that we wanted to take forward. The rest of this year is going to be focused on building up towards our Minded To decision, which we're going to publish in late autumn this year, alongside a detailed impact assessment of what the changes could mean for a wide range of consumers. And that'll be a consultation, so stakeholders will have the opportunity to feed in and help inform our thinking before we publish our final decision in spring next year, with implementation of the reforms in April 2023. So that'll be alongside the new price control review for electricity distribution. And we're really keen to engage with stakeholders, I think, is a sort of key message that we want to get across. And we have a delivery group to engage with network and system operators, with a challenge group that engages with a broader range of network users. And we have our Charging Futures Forum. So this is a wide forum of normally about 150 different stakeholders that come along and help inform and challenge our thinking into all aspects of network charges. So if people are keen to be more involved in this discussion, keen to help inform our thinking, then I'd strongly encourage you to sign up to the Charging Futures distribution list. You can see the link there on this slide. And the last part that I wanted to mention was, if we went way back to the first slide, there were sort of 2 ways in which we could send signals for users to be flexible. One of them is through network prices. The other one is through sort of contracted flexibility, so new markets for users to be able to sell flexibility services to. And we're doing considerable work to try and open up existing markets and develop new markets for flexibility. So specifically at the electricity system operator, National Grid, has a number of existing markets that they use to balance the network, make sure that generation demand are balanced at all times. And we're pushing them and encouraging them and incentivizing them to look at these markets and try and open them up to a broader range of participants. And there's a number of pieces of work that we've got focused on that at the moment. We're also engaging with government to think about the markets that they're able to control and how we can open up some of those markets as well. The other key area that we're working on is around developing local markets for local flexibility services. So at the moment, if you wanted to sell a flexibility service, you could sell it to National Grid at a national level. But there isn't well-developed markets to sell local flexibility services to balance generation demand at a much more local part of the network. So we're working with the distribution network companies to help develop these local markets. They could be a really useful source of revenue for vehicle to grid operators in the future. So we've seen the DNOs have developed a number of tenders. So we've seen some tenders go out from each of the DNOs now. And they're now working together through the Open Networks project to try and develop a common approach for procuring those flexibility services. And we've put out our consultation last year on our proposed way forward for how we should incentivize and encourage network companies to further develop those local flexibility markets. So I think those are the key things that I wanted to talk about today. But I think part of the things that we wanted to really focus on was really identifying that actually our work on TCR is very well developed, it's very well thought through, but it really fits in a wider package of reforms that Ofgem is taking place to help encourage a much more smarter, flexible energy system. And it's really that the TCR should be seen alongside those other reforms that we're trying to push forward. So I think that's it for me. Do we have any questions?
So thank you very much for that, both Stephen and Eleanor. So we do have some questions coming in. So I'll go from the top down and I'll direct them to both of you, and you can answer as you see fit. So the first one is, considering the reason for storage is to provide network balancing services, for EVs doing vehicle to grid, can DUAS tariffs be developed specifically for storage behind the meter? Question mark.
So I think what we're really focusing on as part of our access and forward-looking charges review are getting network charges that accurately reflect the benefits, whether that's be exporting or importing electricity onto the network. And on that basis, storage wouldn't be any different to any other type of demand, or wouldn't be any different to any other type of generator that's importing and exporting electricity onto the network. So I don't think we're looking at specifically a type of charge just for storage users. What we're really focused on doing is trying to make sure that if those storage users are importing or whether they're exporting, that the charges that they incur reflect the costs or benefits that they're creating on the system.
Thank you very much for that. So next question from Chris Wright. Do you see charges to households varying between areas significantly?
So I think this is one of the key things that we've been looking at, both under the targeted charging review when we've been doing our impact assessment and thinking about what the impact is for domestic users, as well as through our access SCR and what that could mean for different domestic users. And when I identified the three guiding principles that we're using to assess options under the access SCR, the middle one was around energy being an essential service. And that's really thinking about domestic users and how much we should expose them to sort of cost-reflected price signals. So should we fully expose users to very much more sharper locational and time of use signals, or should we, acknowledging that these are users that are reliant on electricity for heating, for light, for cooking, should we dampen down some of those price signals? And the downside potentially being of that is that it might have a negative impact on our first guiding principle, which is about efficient network development. So we're really trying to think about some of these trade-offs between efficiency on one side and trying to ensure that the arrangements are appropriate for domestic users. And that's something that we put some initial thinking out on our working papers last year, and it's work that we're continuing to assess, and there will be a lot more information about where we do end up and what the potential impact could be for different domestic users as part of our impact assessment that we publish later this year.
Thank you very much for that. So this is for Ofgem. So for you guys, rules, regulations and charges for a virtual private wire? Question mark. Quite an open-ended question. So
it is quite an open-ended question. So I guess people's idea of what a virtual private network or virtual private wires, there's sort of lots of different sort of ideas for what that could look like and how that could operate. And certainly some of the options that we're thinking about under our reforms might help achieve some of the objectives that those kind of virtual private networks are trying to achieve. So under access rights, one of the options that we're thinking about is the ability of users to share access rights. So instead of an individual user sort of agreeing their own access rights, they might be able to share a common access right with one or two other users themselves, and that type of access right might be quite similar to how some people interpret that virtual private wires. So certainly kind of, yeah, hard to be specific, I guess, on it, but if there are sort of more specific things that people wanted to talk about in relation to that, and how our reforms might be able to help enable some of the similar sort of objectives that they're trying to achieve, then happy to follow up afterwards.
Thank you very much. So next one's from Ian Ryan. Is there a way we can discover which areas are nearly demand constrained and maybe flipped into that category if several organisations want to install rapid EV chargers? It's in/out at the moment. So how to determine a demand constrained area?
Yeah, so we are pushing the network companies to provide a lot more information about what parts of their network are constrained, and what their plans are for going forwards to address those constraints as well. So I think we've seen some of the network companies, not all of them yet, publish heat maps on their websites where they will you can go on, you can log around, zoom around each of their different areas and see how much capacity or how constrained they are in different parts of their network, how constrained each substation is. So we're beginning to see sort of improvements in that area. But we are pushing the network companies and engaging with them to go further on that.
Stephen, do you know off the top of your head what would be the forum for people in this group to engage with the network companies on that project?
So certainly, yeah, so there's probably two best ways of engaging. Firstly, there's the ENA Open Networks, which has a steering group and advisory group that has a broader range of users that are participating in it. And that's probably one good forum. The other one that I would probably plug, so we have one of our incentives that we use to drive network companies to deliver good engagement with connection stakeholders is what we call the Incentive on Connections Engagement, so the ICE. And we consult each year about how much network companies are engaging and responding to the needs of their connection stakeholders, and making changes in their business to meet their expectations. So that would be the other key area that I probably plug. And certainly we'll be consulting in the next few months about DNO's current ICE plans and how much they're addressing concerns such as this one.
Cool.
Okay. Thank you very much for that. Sounds like an interesting area. So this question is about, will there be, and I think you touched upon it on your presentation, will there be a replacement for Duos to incite time-dependent EV charging? Which changes planned for Duos, and would there be any special rules for V2G as a result?
So as I mentioned under the distribution, are part of our wide-ranging review of distribution network charges, and we're thinking about the design of those charges. So how much should we rely on time of use charges? How much should we rely on capacity charges to send signals to users about their cost on the network? So that's one of the key things that we're thinking around at the moment, and yeah, time of use options are one of the options that we're considering and thinking about. And certainly going back to the point around specifically for vehicle to grid, again, it really shouldn't vehicle to grid shouldn't be any different to any other type of user that is importing or exporting electricity onto the network. So our key focus is going to be making sure that the charges are reflective of the costs or benefits of doing that, rather than sort of treating vehicle to grid differently to any other type of demand or generation.
Thank you very much. So again, I think you touched upon this a little bit within the presentation on certain aspects, but how is it best for the vehicle to grid community to communicate with Ofgem on a two-way basis? Because obviously you've got your consultations, but are there other ways? Are there more informal ways, or?
Yeah, so certainly our formal consultations, when we go out with those, are a really good mechanism for us to put information out there and for users to respond to that. But I think that the Charging Futures Forum, I guess, would be the key mechanism that I'd look at alongside that as well. So it meets on a quarterly basis normally, and has a wide range of sort of participants that are interested in network charges. Some of them may be very familiar with network charges. Other people are not as familiar with network charges at all. So if there's people on the call now who are concerned that maybe they wouldn't feel as though they knew enough about network charges to get involved with that forum, we really do try and make sure that it's accessible to a broad range of different stakeholders. And that is very much a discussion. So it normally works that we present, or one of the network companies or National Grid ESO presents, depending on what the topic is. And then there's a lot of breakout discussion. There's a lot of two-way discussion as part of that. So I think that would probably be a really good place to have those kind of discussions. And in my slides, I forwarded on the link to the Charging Futures distribution list. So people who are interested in coming along or getting involved. So we also do webinars and things alongside that as well. Then signing up to that distribution list, you get to see all the different things that we're doing through it.
Stephen, is there anything else in your work on EVs with BEIS, any forums that sort of meet on an ongoing basis, or CFF's the main one?
The CFF is probably the best one in terms of network charges. I think if users wanted to have a sort of a broader conversation, then certainly the EV Energy Task Force is probably a good forum to have that. So we're a member, government's a member, but also a wide range of both energy and transport stakeholders are part of it as well. And there was a EV Energy Task Force report that was published earlier this year. And there are a number of the things that have been talked about in this webinar are similar things, similar themes that are touched on that report. And they're very much focused about trying to actually make sure that change happens and monitoring those changes that are happening on sort of the key areas of their recommendations. So, that could be another useful forum that people can get involved in. So the EV Energy Task Force, I can circulate some information around on it.
That would be great, and if you circulate that to me, then we can make sure that's get disseminated within all the attendees. So the next question is, the requirement to pre-qualify every V2G charger separately is not typical when compared to other European markets. Would Ofgem be able to influence future products to ensure compatibility with vehicle to grid? So I guess this question is about how closely you look at what's going on in European markets, and obviously our electricity network is a bit different, and also links to your influence on future products.
Sure. So we definitely do engage with those European markets and the other European regulators as well to see what's happening over there. And specifically here in GB, we are engaging, encouraging, incentivizing the system operator, National Grid ESO, and the distribution operators as well, to be looking at how they can broaden out these markets to ensure that they are that a wide range of users are able to participate in them. And where people are identifying barriers such as this one, we're really encouraging the National Grid ESO to make sure that they are considering and addressing those barriers. So yes.
Thank you very much. So this question just come in. If we want to move users from gas to electric, how do Ofgem propose to prevent users sweating the existing gas asset to avoid their fair share of electricity reinforcement costs?
So I think certainly we're looking as alongside what we're our reviews on the electricity network side. We're also looking at charges on the gas side, and thinking about the sort of the future of gas and the future of the gas networks. So a lot of the focus of certainly my work and Eleanor's work is very much more focused on the electricity side. But yeah, there's similar work happening on the gas side to make sure that we are sending the right signals to users about their behaviour.
Yeah, and I think for some more details on that, probably the best place to refer the group would be the Ofgem's Decarbonisation Action Plan, which I think was published in January. It was either January or February this year. It sort of would give an idea of the different areas where we'll be focused. And I think, you know, the future of gas and the gas network is certainly going to become an increasing focus over the next few years.
Great, thank you very much both. So again, another question that's just come in. Will any of those you mentioned a few minutes ago, and I'm not sure what a few minutes ago links to, have a correlation with the export limitation schemes like G100?
Are you familiar with that one, Stephen?
I'm trying to think if I can. It's when we can take away. It's when we can take away. And if anyone wanted to be wanted to come back and be more specific on exactly that question, then yeah, happy to follow up with that.
Okay, George, if you could try and find some more information on that, maybe in the next minute or two, then we could potentially re-ask that in a slightly different way. So another question here, this is regarding current measurement and verification requirements from National Grid are prohibitive for any residential flexibility, including V2G. Any plans to persuade National Grid that a programme designed for residential is needed?
So as I sort of mentioned in the previous response, we are keen to ensure that the National Grid ESO's flexibility markets are open to the broadest range of potential market participants. You know, the more people we can get operating and working in those markets, then hopefully the most efficient outcomes will happen for consumers. So we're engaging with them, we are incentivizing them, and we're working with them to help ensure that they're opening up those markets.
Stephen, is it fair to say that on those flexibility market questions, one of the best ways for people to engage would be on the Smart Systems and Flexibility Plan next round iteration? I'm aware. So Simon, I don't know if you've given the group many details about that, but the BEIS had been planning to do a series of workshops with us before the lockdown started that have sort of been somewhat postponed, but there is a team within BEIS that are still quite active on consultation on these types of issues through the future of the Smart Systems and Flexibility Plan.
And I think that would be really good. Another thing, a really good thing that we could send out to the group and make sure that everyone's fully aware of that and how they interact with that. That'd be really useful.
Yeah.
Okay. So the question just got a bit of clarity on that previous question. So the question regarding G100, it was referring to connection boundaries. Does that make more sense?
What was the original question again? Sorry, just to.
So will any of those you mentioned a few minutes ago, so presumably connection boundaries, have a correlation with the export limitation schemes like G100?
I can't. I'm struggling to think through on the top of my head how the two potentially could link together. But let me take it away, and I'll come back on that one.
That's perfect. Thank you very much for that. So We've got a few minutes left, and we've answered all the questions that have come in. So we've also tried. Thanks very much to the people who sent in questions prior. I believe we've answered all those as we've gone along and with the presentation, and including some directly. So we're now going to come to the close of this webinar session. I think firstly, thanks to all the speakers and all the attendees. I think it's been a really interesting discussion about vehicle to grid. It's really nice getting input from different angles. I think that's the way these kind of innovations are going to be brought forward. I think without working together, it's very hard. There is also a option at 1:30 to meet other people with our online video chat service. So you get 10 minutes. You should have received an email for that, which will tell you how that all works. So that starts at 1:30. Also, just thanks to Olev and Bays, they obviously provided a lot of the funding for the vehicle to grid projects, and that is actually crucial in terms of letting the UK become a leader in some of these areas. So, and also thanks to George for manning the chat. So thank you very much, everyone. I hope you're taking care in this slightly weird world. And if you've got any questions, feel free to pop me an email, and George will have put that on the chat. So thank you and bye.